Hey everyone, welcome back. Today we are going to look at another LeetCode daily challenge, and today's problem is uncommon words from two sentences. Given two sentences S1 and S2, we have to return a list of uncommon words. A word is nothing but collection of letters not containing space. And when is it called uncommon? It is called uncommon if and only if it appears exactly once in one of the sentences and does not appear in the other sentence. Let's try to look at some examples to get a clear picture of what the problem statement is. Let's look at all the words of sentence 1, one by one. This appears once but is also present in sentence 2, cannot be called uncommon. Apple, present once, also appears in sentence 2, so it cannot be uncommon as well. Is appears once exactly in sentence 1 but is also present in sentence 2, cannot be uncommon. Sweet appears exactly in sentence 1 and is not present in sentence 2, so it is there in the answer. Same goes for sour, present exactly in sentence 2 but not present in sentence 1, hence it's there in the answer. Let's look at the other example as also. Apple appears twice in sentence 1 itself, so forget about the other condition. It should have appeared only once to be even considered to be uncommon. How about banana? Appears exactly once in sentence 2 and does not appear in sentence 1, and it's there in the answer. So I think we can use a hash map to count the number of occurrences of each word for either of the sentences, and then maybe check one by one if each word satisfy both the conditions. That is, it should appear exactly once in that particular sentence and it should not be present in the other sentence. Let's see how we can do it. Let's create two maps, one for each sentence. So map 1 corresponds to words in sentence 1. So this appears once, apple appears once, is appears once, sweet appears once. Let's create another map for sentence 2. This appears once, apple appears once, is appears once, and sour appears once. Now let's go one by one for every word in sentence 1. This appears once but is also present in the other sentence, so this cannot be. About apple? Appears once but also present in map 2, so cancel, cannot be uncommon. Is appears once and is also present in sentence 2, cancelled. Sweet appears once and is not present in sentence 2, hence sweet can be called uncommon. Same, let's go for all the words in sentence 2. And this appears exactly once but is also present in sentence 1, so cannot be called uncommon. Same goes for apple, same goes for is, and sour present exactly once in sentence 2 and is not present in sentence 1, so yep, this is another uncommon word that we got from sentence 2. So what would be the time and space complexity of this program? Time complexity would be big O of n1 plus n2, where n1 is the length of sentence 1 and n2 is the length of sentence 2. Space complexity would also be big O of n1 plus n2, because we are using two maps to store the word frequencies for each of the sentences, and they would ultimately sum up to the length of the individual statements. Yeah, time and space complexity both are big O of n1 plus n2, where n1 and n2 are lengths of each of the sentences. Let's try to code this up now. Okay, so let's create result vector. This will at the end contain all the uncommon words and we will return this as our answer. Let's create an ordered map, one for S1 and the other for S2, containing the word counts. Now let's create a function that populates both these maps by traversing each character in either of the sentences. We'll define it later on. For now, let's just assume that it does its job. So it takes in two arguments. One is the sentence itself and its corresponding map. Now that we have our maps ready, let's go through each word in each of the maps and check if we can find an uncommon word. So we need to check if it appears exactly once and it does not appear in the other map. If it is true, then we have an uncommon word. So we'll put it into the result. We have to do the same for the other sentence. Loop through all the words in sentence 2. Check if its value is 1 and it is not present in sentence 1. That's it. Finally return result. Let's go ahead and define the helper method. Accepts two arguments. One is the sentence itself and the other is the okay. So I'm taking a variable to keep track of the current word. Okay, and just like that, traverse every character in the sentence. If the character is a space, that means we have found a word and we need to push this in our word count map. After pushing it, we need to reset it. If it is not a space, I simply add the current character to my word. That's it. Now, one thing to notice is by the time we reach the end of the statement, there is no space, which means we won't be able to add the last word in our word map, a word count map, via this for loop. So we have to handle it separately. So I'm just putting the last word found in the sentence in the map outside the for loop. That's it. Let's see if we can run the example test cases. And yes, they work. Try to submit it and it gets accepted. Great. If you enjoyed this video, be sure to like and subscribe for more LeetCode solutions. See you in the next one.